So this is a geometry problem. So we're basically given a rectangle. Yeah, so we're given a rectangle A, B, C, D, with AB equals 6 and BC equals 3. Okay. And E is between B and C, and F is between E and C, such that BE equals EF equals FC. So that tells us E is going to be here, F is going to be here, and okay, this diagram is kind of small. So like, let's say you have your rectangle, A, B, C, D. They told us AB is 6, and points E and F lie on BC like this. They told us BE equals EF equals FC. So each of these has length 1, because they told us BC has length 3. Okay, now it says segments AE and AF, AE and AF intersect BD at P and Q. So you have AE, you draw AE, draw AF, and you draw BD. And you have AE intersects BD at P, AF intersects BD at Q. And we want to find the ratio BP, so this length to this length to this length, BP to PQ to QD. That's the ratio we want to find. All right, so the important thing about this question is something called similar triangles. So AD has length 3, right? So one observation we can immediately get is triangle, is that, okay, let's see, is that triangle APD, right? APD, so like this triangle, APD is going to be similar to triangle EPB. And the reason is because like whenever you have like parallel lines, like AD is parallel to BC because that's like, since ABC is a rectangle, then triangle APD is going to be similar to triangle EPB. And parallel lines are going to generate similar triangles because like this angle, for example, this angle is equal to this angle by alternate interior angles. And similarly, like this angle is going to equal like this angle by alternate interior angles. And if you have two angles in two triangles that are the same, then you know they're similar. So we know triangle APD is similar to triangle EPB. So that kind of gives us some information, right? We know that BP over PD by similar triangles, like this length divided by this length, is going to equal BE divided by AD, since these two triangles are similar. So BP divided by PD is going to equal 1 divided by 3. So we already got some nice information on our ratios. Yeah, and then now what we can do is we can kind of use similar triangles again. We can notice that triangle, okay. It turns out triangle like ADQ, I'll write it as AQD. Triangle AQD is similar to triangle FQB. So, okay, so triangle AQD is this one. So triangle AQD is this yellow triangle. Is similar to like this green triangle, FQB. And this is kind of like by similar reasoning, right? Since like you have alternate interior angles and they have the same angles, so they're similar. So we can kind of like, we know that BQ over QD is going to equal BF. So we have, let me write it here. So we have BQ divided by QD is going to equal BF over AD by similar triangles, which is going to equal 2 over 3. Okay, so let's call this like let's call BP, let's call it X, just so it's easy to write. Let's call QD, let's call it Y, and QD, let's call it Z, right? Just to give variable names to make it easy to refer to. So when we got that, we got BP over PD is 1/3. So we can write that as X over Y plus Z, right? Yeah. So we get X over Y plus Z is equal to 1/3. And we also get that X plus Y divided by Z is equal to 2/3. Right? All right. And we want to find the ratio. We want to find the ratio X to Y to Z, because that's what the question is asking. So basically, what we want to do is we can kind of like take this equation and multiply both sides by Y plus Z, multiply both sides by 3. So you would get Y plus Z is equal to 3X. And for this equation, you would get 3X plus 3Y is equal to 2Z. Okay. So now what we can do is we can like eliminate one of the variables. So from this equation, we can say Y is equal to 3X minus Z, right? So we can substitute that into the second equation. So we can plug that into there. So we would get 3X plus 3 times 3X minus Z equals 2Z. So here, this is equal to 9X minus 3Z. So we would have 12X, because you have 3X plus 9X, and you move the 3Z to the other side, this equals 5Z. Okay. And from here, what you can do is, like, you can say, I guess, you can say that Z is 12 over 5X. So if you were to plug that into here, you'd have Y is 3X minus 12 over 5X equals 3 over 5X. All right. So now we want to find the value of the ratio X to Y to Z, right? That's what the question was asking. Then we can write X to Y to Z as Y is 3 over 5X, we just found. And Z is, we just found 12 over 5X, right? So we can kind of just multiply, to find this ratio, right? We can divide everything by X, because X is like, X appears everywhere in the ratio, so you can just divide it out. So this is equal to 1 to 3 over 5 to 12 over 5. But since like you can't have fractions, right? Like the question says that, like, the ratios R to S to T, where the greatest common factor is 1, and they're integers. So you would have to multiply everything by 5 to make everything an integer. So you get 5 to 3 to 12. And the question wants the sum of these three numbers. So you do 5 plus 3 plus 12, and you get 20, which is choice E. Yeah, so it's choice E.